Okay, this is the part 3 of chapter 11. Let's get right to it. This is where we ended up at the end of part 2. Um, going into bearing lubrication. It's a good mix and match problem for the final type of thing. Good summary of purposes of bearing lubrication. Primarily, it's used as a lubricant. um, Basically to separate the rolling surfaces, but it's also used to distribute and dissipate heat, prevent corrosion, and protect the parts from foreign matter. Um, so the actual grease or oil or whatever is going through your bearing actually serves multiple purposes. Again, as I mentioned in the previous slide, oil or grease can be used. Here's the guidelines for when to use grease and when to use oil. The biggie is temperature. Once you get over 200 degrees, your grease will basically liquefy. So, grease is used on relatively low temperature, low speed uh, bearings that probably have a lot of junk in the environment, a lot of dirt and foreign matter. So you're going to have some sort of shield on the bearings, and you basically just want a cheap bearing that'll run forever and ever. Not literally, but just run for long periods without really needing a whole lot of attention. Uh, Oil. This is used for high speed, high temperature um, applications. This is basically it. You have high speed, high temperature. You have to transition to oil. Oil is also used to remove heat. So I would put 6, remove heat from particularly high speed bearings. You're actually cooling the bearing down with the oil. Here's some common bearing mountings. This is the same shaft. They just sort of, this isn't two different shafts. So this is one shaft. And they're just showing that the shaft is a lot longer than shown in the picture. Figure 1110, this is radial loads only that you're, or I would say, no, they're showing thrust in one direction. The second one is thrust in two directions. Again, some common mounting configurations. You can see, where it's buckled down to the stationary part. And so you're pushing on, you notice that in this right-hand instance, you're tightening the tapers. So let me pick a different color. So the load path is through this way and down to that way. So that keeps the bearing trapped on there, preloads the bearings against each other, and definitely in that configuration capable of significant radial and axial loads. Here's a vertical shaft. You have to be careful with vertical shafts not to unload one of the bearings due to the weight. So you have the weight pulling down, and so in this case, the top bearing is going to be more heavily loaded due to the weight. So this one is more heavily loaded due to the weight. And this actually caused a test rig at OSU to blow up 3 times. They took a horizontal test rig and made it vertical. They completely unloaded the bottom set of bearings so that they basically weren't adding any stiffness to the system. And the thing just flapped around there at high speed and destroyed itself. So you have to be careful when you're supporting the shaft weight or significant axial loads in general that you don't completely unload one of the bearing sets. Duplexing. This is very common. I mentioned this in class at some point. You have these are called angular contact bearings. So we have angular contact bearings, and you basically load them up against each other to give you some. When we talked about this when we talked about Hertzian contact. So, whoops, I misspelled it. Hertzian contact. You have force versus deflection, and it gets stiffer. So the whole idea is to load these bearings up against each other, somewhere around here, to give it a higher stiffness. So the stiffness would be the slope of this thing. Right? So let me redo that. Whatever the slope of that thing is the stiffness. So you're basically clamping these bearings together to preload them. The more you preload them, the stiffer they get, the higher the forces they can carry, and the more rigidly they maintain alignment. Here's some common duplexing arrangements. Some of them are the same direction, some of them are opposite. So these first two, or A and B, I should call them, as they're labeled A and B. These are for thrust loads from either direction. In C, this can only take thrust in only one direction, but you're still loading the bearings up against each other for extra stiffness. Preferred fits and preloading. So when you buy an off-the-shelf bearing, you'll notice if you shake it that you can hear that there's a clearance, and usually that's taken up when you press fit it onto a shaft. So you need to press fit those things. If you're just sliding them on fit to fit, you're not installing the bearing correctly. So you want to remove that internal clearance. So you really need to size the bearing correctly, so that so you really want to remove the internal clearance here. That'll increase the fatigue life. It'll increase how that bearing aligns the shaft. Obviously, if there's slop in here, if you have some slop in here, the shaft's going to have an extra degree of freedom that it shouldn't have. So make sure that you get the fit and the preload right for the bearing. Other than that, these things can't really take a whole lot of misalignment. So if you have multiple bearings, this becomes an issue, or if you have high shaft loads. So a couple things that could cause angular alignment misalignments. You notice these are in angles. So this can be, angular misalignment can be caused by either having multiple bearings. In other words, more than two on the same shaft, or you have a long flexible shaft with high radial loads. That's the biggie right there. And I would suggest that when you do your assembly drawing of your design in a finite element package like SolidWorks, that you put on some loads, calculate the angles that result at the bearings, and just double check. This is a good simple table for double checking that you didn't edge load the bearing too much. And here we are at the last slide, enclosures. Usually when you buy an off-the-shelf bearing, It's like the deep groove ball bearings, the cheapies that go into most things that you'll design. They usually already have a seal on them, uh, or a shield that keeps the grease in. They're pre-greased. You don't have to do much with them. You can pretty much ignore this. It's when you're getting to larger bearings, high load, high speed, that now you need to seal up the basically the oil that's lubricating your bearing. So this enclosure is usually for oil lubricated bearings only. Usually grease bearings are um, prepackaged like that. That's all self-contained. Sometimes not. Sometimes there's a little grease nipple that you gotta put more grease in every now and again. But um, with those you don't need a seal. The grease just kind of leaks out over time, and you gotta put more in now and again. The one thing I want to point out here is this labyrinth seal. Uh, you really ought to do some independent research on that. These things are pretty neat. They're all over the place in high-speed turbo machinery. They've got grooves on the shaft and or lands, and these little eddy currents in this area here essentially choke the flow. It's a pretty neat fluid dynamics phenomenon. What happens in a labyrinth seal? This would be a independent research moment for you. If you want to see something that's mechanically extremely simple but uncommonly effective, that's the and also very prevalent in a lot of high power rotating machinery. That would be the labyrinth seal. There's all sorts of packings. This is like a packing, and the commercial seal. They don't all look like this. Um, there's oodles of these, so um, there's numerous options. And usually you're going to go with an OEM recommendation, no matter what. If you need a seal, go with what the OEM is recommending. That's pretty much it for, that was a short part 3. That's it for chapter 11. Let's get back to the first slide. Here's where we started. Rolling contact bearings, we're done with it. So last note, chapter 12. There's no online lecture. There are already PDFs are already posted. So if you've watched all parts of chapter 11 and you read chapter 12, you'd be up to date so far until Monday the 26th, November 26th. So when a new lecture will come out, if not before then, we're going to be covering, I believe, gears next. I'll have to check that, but I think it's like a combined chapter 13, 14, and 15 is what's coming up next. So that's it for chapter 11, and I'll talk to you in the week after Thanksgiving.